In this next example, we are going to be solving for different things other than future value and present value. We are going to find out interest rates, and we're going to solve for time. Now, the interest rate is a pretty straightforward one, but with the time is embedded in this n number. We're going to have to do something with the total number of compounding periods to be able to solve for how long something will take. So let's, before I get too ahead of myself, let's read through the question. So Lena has invested $16,000 in a registered education savings plan, or an RESP. She wants her investment to grow to at least $60,000 by the time her newborn enters university in 18 years. So A, what interest rate, compounded annually, will result in a future value of $60,000? Round your answer to 2 decimal places. Then part B, suppose Lena wants her $16,000 to grow to at least $70,000 at the interest rate from part A, but compounded quarterly. How long will this take? So, let's do question one. Again, what I like to do is I like to start out with my compounding period per year so that my n will fall into place nicely. So, we're saying that it is compounded annually, so my PY and CY will be 1. For all intents and purposes, for the next, set of questions, PMT will always be 0. Our future value, we want it to go to 60,000, 60,000, and the initial investment, or the present value, is 16,000. Now here's the tricky bit, folks. We need to remember that negative. Okay, so because the money is going away from Lena initially to come back as $60,000. Ta-da! Now we know that it's compounded annually, so the number of compounding periods per year is 1 times 18 years, and we're solving for that interest rate, so we're going to put a dot by it. So let's plug it into the calculator, TVM Solver. I know it's 1 times 18, or just 18. I'm going to skip over the interest rate because we're going to come back to solve for it. My PV is going to be negative $16,000. Our PMT is going to be 0. Our future value is going to be 60,000. And our PY and CY are both going to be 1. So I'm going to go back up to my interest rate. We're going to go alpha, enter, and look at that. 7.619. Oh, but we just need 2 decimal places, so 7.62. My answer here is 7.62. And just to highlight that this is what we're solving for. It's important that you indicate which one you're solving for, so that when I mark it, I know that you're not just solving for the future value, but you're actually solving for what I want you to. So that's the answer to A. Woohoo! Let's look at question B. Suppose Lena wants her $16,000 to grow to at least $70,000 at the interest rate from part A, but compounded quarterly. How long is this going to take? So I know that my interest rate is from before, so I'm going to put in 7.62. My initial investment is going to be the same. It's still going to be 16,000. My payment is still 0. My future value changes though. I'm going to want it to be $70,000. Compounding periods per year is going to be quarterly, so we're going to have 4. What we need to solve for is n. So I'm going to go back here. I'm going to change this because it's a little bit different, right? It's not 7.619, it's actually going to be 7.62. My negative 16,000 is the same. My 0 is the same. My future value though is going to be 70,000. And my payments per year and compounding periods per year are going to be 4. I'm going to scroll up to n, and that's what we're going to solve for. Alpha, enter. We know that it's going to be, let's go back to it, 78.21. So that means after 79 compounding periods. We will have more than 70,000. I can't say 78 because after 78 it will not have reached that 70,000. So no matter what, with n we have to round up to 79. We're saying 79 compounding periods were compounded quarterly. So what we need to do is, to get the number of years, we say 79 divided by 4, 19.75 years. So it will take 19.75 years. Another way you could have answered it is just saying after 79 compounding periods that are compounded quarterly. That could also be one, but this is the fullest and best answer because it gives us a really good sense of how long this went on for.